Ooh.
All right, so today we're going to spend a second day on 6.5, which we yesterday did square root equations. Now we're going to look at different radicals and different powers. And if you remember from yesterday's notes, we said if it has a radical, that's a radical equation, but it could have a fraction exponent. And we'll see that in example 2. So this is going to get a little bit more difficult, but not much more difficult. So I think if you just stay with me, you're going to be fine. So in example 1, it says solve x plus 1 cubed equals negative 27. So this really does tie into, CJ, what you were talking about. Like, how do I undo to the third power? Yeah, Emma? Well, this is cubed. You mean cube rooted, right? Yeah. Okay, so here we go. I'm going to do a cube root to both sides because a cube root of something cubed is x plus 1. If you have your pink paper with your powers, the cube root of negative 27 is negative 3. Subtracting 1, x is negative 4. All right, I'm not getting any extraneous solutions because that's an odd root, okay? Yeah. Sure. All right, now, in example 2, don't work ahead of me because that might get you into trouble. Thank you. Okay, so keep in mind, x plus 1 to the 2/3 power, that's my radical. Step 1 still holds true. You need to isolate the radical. So a radical comes in 2 forms. You can have a square root of something, and you can have a fractional exponent. Okay, do you remember that? Where we did like 36 to the 1/2 means the square root of 36. So a 1/2 power is in fact a radical. So now, watch this. I'm going to rewrite this as the cube root of x plus 1 squared equals 4. Okay, just kind of stay with me here. When you have a fraction exponent, remember I told you a silly story about a root cellar. So my root is in the basement, in the bottom of the fraction. So that's my root is 3. So now, I'm going to tie in this to example 1. I want to undo a cube root. How do I undo a cube root? Cube it, okay? So, what I do to the left side, I do to the right side. So that's going to undo the cube root in the cube, but it's going to leave me with x plus 1 squared. If you have your pink paper, 4 cubed is 64. Now, I need you to stop and think. We did this previously, okay? This is where you got to be really careful. Do you understand that what's inside this parenthesis could be 8 or it could be negative 8 because it's a square, right? Now I want you to stop and think. What's in here could be 8 because 8 squared is 64, or what's in here could be negative 8 because negative 8 squared is 64. Okay, so watch what I'm going to do here. Be careful. This is going to be plus or minus the square root of 64. This is the trickiest part to it. And this is where, I've talked to you about it at your thinking cap. I really need you to be thinking. So you don't want to go procedure, and try to be the first one done. We want to just go nice and slowly and think about it. So now I'm going to subtract 1 from both sides of the equation. And I know how to add and subtract with numbers. Negative 1 plus 8 is 7. Negative 1 minus 8 is negative 9. Yeah. You actually could. You could FOIL it out and get everything on one side equal to 0 and factor. And if it didn't factor, you could do quadratic formula. Okay, did you guys hear her? She said, why didn't I do x plus 1 times x plus 1, FOIL it? I could do that. That's another option.
I figured it out.
You figured it out? Okay. All right, so let's try another one of these in example 3. All right, it says solve 3 times the 5th root of x plus 1 cubed plus 1 equals 25. So think about the steps I gave you yesterday. Isolate the radical. So that's the first thing we do. So we're going to subtract 1. And then I'm going to divide by 3. So I have the 5th root of x plus 1 cubed equals 8. All right, so you might want a calculator. And what do I need to do first? Okay, Jacob, do you know? Yeah, we're going to get rid of the 5. Since it's a 5th root, we're going to raise it to the 5th power. So that's going to give me x plus 1 cubed equals. So I grabbed my calculator because 8 to the 5th is huge. It's not on that pink powers paper. So I'm getting 32,768. Now, I've got x plus 1 cubed. How do you undo a cube? Cube root. So do you see? Sometimes you raise it to a power if it's a root, and if it's a power, you do a root. Do you see, to undo them? So this is kind of cool. So now I'm going to do the cube root. But let me ask you, based on what we did in example 2, do I need a plus or minus? No, I don't, because it's an odd root. Odd roots only have one answer. Even have 2. Okay, so be careful with that. So I'm getting x plus 1. So do this on a calculator for sure, because we don't know this one. The cube root of 32,768 is 32. Subtracting 1, x is 31. Make sure you know how to use your calculator, whether you're using the graphing calculator or the red OGT calculator. All right, then the last problem is like an application. Who cares? Like, why are we doing this? Here's an example. It says, for meteor crater in Arizona, the formula d equals the cube root of v over 0.3 relates the diameter of the ring in meters to the volume v in cubic meters. What is the volume of the meteor crater if the diameter is 1.2 kilometers? Now, again, we've talked a lot today about your thinking cap and having that on. Do you notice that it's talking meters, cubic meters, and then it gave me kilometers? Those are not the same units. Recall, either from physical science or an earlier math class, 1 kilometer is 1,000 meters. Okay, 1 kilometer is equal to 1,000 meters. So when I have 1.2 kilometers, that's 1,200. So it's not 1.2. You'd get the problem wrong if you put 1.2 in. So it's giving me the diameter. And it says in the problem the diameter has to be in meters. So when they gave me kilometers, I had to do a unit conversion. So I'm going to cube both sides. And this is going to give you a really big number. I got 1,728,000 equals v over 0.3. And then I need to clear the fraction, so I'm going to multiply both sides by 0.3.
you want us to round it?
There's no rounding here. This turns out to be a whole number. So I got 518,400,000. This would be meters cubed. Yeah, I didn't have any decimal. Maybe yours gave it to you in scientific notation.
Yeah.
Yeah, okay.
Is there a way to change that?
I do not know. Stay to video. Okay.